Hi, grade 11s. Welcome to the first session of the winter school. This session, the theme is looking at the chemical industry, particularly because of stoichiometric calculations. So I would just like to start off by showing you this question, which is from the grade 12 paper. Now, the question is about rates of reactions, and you haven't done that yet, but you will see here, question 5.2.2, it says use the information in the graph to calculate the mass of hydrogen peroxide used in the reaction. Now, in order to do that, okay, you have to read off the volume of the gases, and then from that you calculate the mass. So in order to do that, you need to use your stoichiometric formula, the amount of substance and so on. So I thought it was very important to revise stoichiometry in detail in the winter school. Firstly, because it does form part of the grade 12 exam. Secondly, it's very important in terms of the chemical industry to be able to know the amounts of substances to use during different reactions. So I hope you find these sessions useful and that it will help you revise your stoichiometry and become well acquainted with the idea of the mole concept. So, grade 11s, just to revise some basics. If you remember from grade 10 and the periodic table, the atomic number tells you the number of protons in an atom. The mass number tells you the number of protons and neutrons. Now, that is the number that is given on the periodic table. So that mass number is the number of protons and the number of neutrons in an atom. However, that number is quite unique because if you multiply it by the number of particles in 1 mole, which is Avogadro's number, then that mass in grams is equal to the same value. So that's very important to remember, and it's quite useful when working with stoichiometry. And that's what today's lesson is going to focus on, is working out the mass of the particles that is required to be able to do stoichiometric calculations. Okay, and so you're going to be using that mass number to complete the exercise that you have been given. What I've done is I've given you a list of various chemical processes. You have to identify the chemicals involved, write down their formula, draw a basic diagram, and work out their relative formula mass. I prefer to use relative formula mass because that covers all the substances. For example, you can't say sodium chloride's relative molecular mass because it's not a molecule. So let's rather use relative formula mass when we talk about that mass of one particle. Okay, so good luck with the exercise, and remember, you'll need a periodic table, so please have that close by. So let me just do an example with you. You see here it's called relative formula mass. So it's calculated by adding together the atomic masses of all the atoms shown in the formula. So I'm going to look at the example of ammonia, NH3. So the relative formula mass of ammonia must be the relative mass of hydrogen, which is 1, and nitrogen, which is 14. So let's quickly look at those answers. That is what the oxygen molecule looks like. So oxygen, if you go to the periodic table, has a relative atomic mass of 16. So 16 times 2 is 32. Now let's look at sodium nitrate. You will see that this is actually an ion of sodium ion and a nitrate ion. So going to the periodic table, sodium has an atomic mass or relative atomic mass of 23, nitrogen of 14 and oxygen of 16, but there are 3 of them, so it's 16 times 3. So the total mass or relative formula mass of the sodium nitrate is 85 atomic mass units. Now for magnesium hydroxide, it would be the magnesium ion, one of them, attached to 2 hydroxyl groups, which is OH. So oxygen is 16, hydrogen is 1. So that's 17. 17 times 2 is, that's 34, doing the maths in my head. And then the magnesium is 24. So that 24 plus the 34, that gives us a total of 58 relative atomic mass unit. Okay, so now you get to practice on your own, and we'll come back tomorrow.